It's a beautiful day in Reno, Nevada. Oh my gosh, what a... That hurt. Oh, what happened? Oh,
God, are you okay?
oh, somebody just hit me with a car.
No, wait, really?
Yeah. Oh,
Where did they go?
I don't know. I think it went that way.
You know what? We can calculate the velocity of the truck. Here, come watch this. This is what we're gonna do.
We're gonna model the car's movement using AP Calc's FRQ4, where X will represent time and G of X will represent the car's position and will also equal the integral from X to 6 of f of t dt. Let's say the time Retuz gets hit by the truck is 8. Because part A asks us for G prime of 8, by the second fundamental theorem of calculus, G prime of 8, or the car's velocity when it hits Retuz, is equal to f of 8, which we can find from the graph to be 1.
That was a lot faster than 1 mile per hour.
My calculations are not incorrect.
Hey, we should check the acceleration of that truck.
Yeah, alright, let's go.
Let's go.
Ouch! Hey man, we need to check the cameras. We just got hit.
Yeah, I just got hit.
Oh, you want to calculate the acceleration?
Yeah,
Gotcha.
actually no.
We can model where the acceleration of the car is 0 through part B of this problem. So, to find where the acceleration is 0, we're going to have to find points of inflection, or where G double prime of X is equal to 0, or changes signs. First, we can use the equation G prime of X is equal to f of X. Then we can determine that G of X has POI where f of X has relative extrema. This would be at x equals 3, x equals negative 3, and x equals 6. So in terms of the car, the acceleration is 0 at these points.
Nah, man, that car was definitely accelerating. Nah, dude, I know my calculations are correct. All right, whatever you say, man. Hey, are you okay? Yeah, did you see me get hit by the truck? I did. I actually saw that truck. It was at 2 different points in time. No way.
Here, bro, show us.
Alright, so basically...
To get to the car's position at 2 different points of time, which according to part C of the question are 0 and 12, we have to find G of 0 and G of 12. We can do this by using the integral given and plugging in the values given and finding the area to solve for these 2 positions. For the first, the graph shows a triangle from the endpoints 6 to 12, which we can simply find the area for by plugging in the base and height, multiplying by 1/2 and getting 9. For G of 0, the graph shows a semicircle on the integrals 0 to 6. We can find the radius as it is 1/2 the diameter, being 3, squaring it and multiplying by 1/2 pi. To find the area, we must also multiply by a negative as the smaller number is on the top of the integral used, giving us negative 9 pi over 2. So that means that at time equals 0, the car was at position negative 4.5 pi, and at time equals 12, the car's position was at 9. Let's see if the truck is at either one of these points.
Ouch! Ouch! My leg! Ouch! Ouch! My leg! Ouch!
Ouch, ouch, ouch.
We didn't find anything.
We didn't either. Yeah, we didn't find anything. Wait, it's gotta be at the absolute minimum. Oh,
Right!
So basically,
we must find the x value at which the absolute minimum is, which we can find by determining where g prime of x is equal to 0 or undefined, or where f of x is 0 or undefined. This is true at x equals 6, 0, and negative 6. Now we can use the candidates test and make a table of these x values in g of x, including the endpoints of the given interval. Then, we can calculate g of x for each x value to see where it is the lowest, which we can find as negative 4.5 pi at x equals 0.
Is this the car that hit you? I don't think so. You know what? Let's go shut the cameras down. Let's go. Ow, 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 okay. Oh, okay. Sure. If it was right there, then. Ah!